Hey everyone, today I'll be going over buffers. Okay, so buffers resist change in pH. They're composed of a weak acid and its conjugate, or a weak base and its conjugate. And to calculate the pH of a buffer, we just treat it like a normal equilibrium problem. So I'm going to give you guys some examples of buffers. Hydrofluoric acid with some sodium fluoride would be an example. Some ammonia with ammonium chloride would be another example. See, this is the weak acid, and this is its conjugate. Likewise, this is the weak base, and this is its conjugate. So, with that said, let's do some problems. Okay, so we want to calculate the pH of a solution containing 0.5 molar acetic acid and 0.5 molar sodium acetate. So as usual, let's start off by making a rice table. So we start off with the reaction, which is HC2, H3O2. I don't have to memorize it, but I'll just write down. And that's going to dissolve to H plus and an acetate ion. So the problem states that we have a 0.5 molar solution of acetic acid. Oh wait, shoot, I forgot to put my ice. Okay, so the problem states that we have a 0.5 molar solution of acetic acid, so that's going to be 0.5 right here. The problem also states that we have 0.5 molar sodium acetate. So that sodium acetate is going to dissolve, producing 0.5. That's going to produce acetate ions. So the initial concentration of the acetate ions would be 0.5, and that's just going to be 0. So now we go to the change. Well, even though that this side has stuff, the equilibrium of the reaction is still going to go to the right because this is 0. So it's going to be minus x here, plus x here, and plus x here. And here are equilibrium concentrations. And now we're good. So now we want to do the sodium. So now we just solve it really. We have the Ka, we're good to go. So Ka is equal to 1.8 like that, and then you do this. Divided by that. Okay. And I know you guys are like, oh my god, we have to multiply all this out. It's horrible. Fortunately, x is going to be really small, so we can ignore these x's. And now it becomes a super simple problem. Actually, x is just going to equal 1.8 times 10 to the negative 5. And now we just calculate the pH of that. Give me a second here. And let me plug that into my calculator really quick. That'll be 4.74. So, yeah. Yeah, buffer problems aren't really that bad. All you have to do is make sure you add the initial concentration. You have to make sure that you take the initial concentration of the conjugate into account. And after that, it's just a normal pH calculation problem. So, yeah, I hope you liked the video, and have a good night, and have a good day, and see you later.